Pythagoras Theorem. The Pythagoras Theorem is applied only to the right-angled triangle. The right-angled triangle is a triangle that has one of its angles at 90 degrees. So you see, it has one of the angles at 90 degrees. So it is a right-angled triangle. The side that is opposite the 90 degrees is called the hypotenuse. And then the other sides may be opposite and adjacent. Now, the formula in Pythagoras theorem is always the hypotenuse squared is equal to x squared plus y squared. You can make x squared the subject. It becomes x squared is equal to h squared minus y squared. You can make y squared the subject. It becomes y squared is equal to h squared minus x squared. So these are the formula or formulae of the Pythagoras theorem. Example number 1. We are going to use the Pythagoras theorem to calculate the length of side x. So, using the Pythagoras theorem, we have hypotenuse squared is equal to x squared plus 5 squared. 13 squared is equal to 169 is equal to x squared plus 5 squared gives us 25. Now let's group like terms. So we are bringing the 25 to this side. So we have 169. This crosses the equal to sign. Minus 25 is equal to the x squared. So when you subtract this from that, you get 144 is equal to x squared. Now we want x, not x squared. So we have to find the square root of both sides. So when we find the square root of x squared, then we find the square root of 144. So this gives us 12. Then this gives us x. So we conclude by saying that therefore the x is equal to 12 centimeters. The Pythagoras theorem and the 3 basic trig ratios are sometimes used at the same time to solve problems. Example number 2, given that sine alpha is equal to 3/5, where alpha is an acute angle, find the value of I cos alpha, II tan alpha, III sine alpha over cos alpha, IV cos alpha minus sine alpha all over tan alpha. We have been given sine alpha to be 3/5. In this type of questions, you can only solve by drawing the right-angled triangle and then calculate for all the sides. So let us draw the right-angled triangle, which I have done on the board. So sine is equal to, as we know, so opposite over hypotenuse. So the 3 is the opposite. So now in determining the opposite, we need to show the angle. So I'm putting the angle alpha to be here. So therefore this side opposite the angle will be the opposite. So this side is 3. And then the 5 is the hypotenuse. And we know that hypotenuse is always opposite to the 90 degrees. So this is the hypotenuse. So we have to calculate for the other side, which is the adjacent, before we can proceed. So let's give this side, the adjacent, to be y. Using the Pythagoras theorem, we have the hypotenuse, which is 5 squared, is equal to the opposite, which is 3 squared, plus the adjacent, which is y squared. 5 squared gives us 25 is equal to 9 plus y squared. Now let us group like terms. So we are bringing the 9 here. So it's going to be 25 minus, because it will cross the equal to sign, 9 is equal to y squared. Now, when you subtract this, you get 16 is equal to y squared. We want y, not y squared. So we find the square root of both sides. So it becomes square root of y squared being equal to the square root of 16. Square root of 16 will give us 4 is equal to y. So we say y is equal to 4. So we put y is equal to 4 here. So we have the right angle triangle with all the sides given. This is a redraw of the right angle triangle. So I says we should determine cos alpha. Cos alpha is ka, so adjacent over hypotenuse. So which side is the adjacent? It is 4 over the hypotenuse, which is 5. II, tan alpha. Tan is toa, opposite over adjacent. The opposite is 3 over the adjacent, which is 4. I, sine alpha over cos alpha. What is sine alpha? Sine alpha is 3 over 5. Cos alpha is 4 over 5. So let us solve. This is 3 over 5, which is divided by 4 over 5, is equal to 3 over 5 times, then we reciprocate this, 5 over 4. 5 goes into 5, 1. So the final answer here is 3, 1, 3 over 4, 1, 4. IV, cos alpha minus sine alpha all over tan alpha. Cos alpha is 4 over 5 minus sine alpha is 3 over 5 all over tan alpha, which is 3 over 4. So this is equal to, now let us find the LCM of the numerators here. So it is 5. 5 goes into 5, 1. 1 times 3, 3. Minus 5 goes into 5, 1. 1 times 4, 4. All over the denominator here, which is 3 over 4. So this is equal to, now when we simplify the numerator here, it's going to be 1 over 5. So it's going to be 1 over 5 all over 3 over 4. Lack of space here, I'm coming to this side. So it's equal to, we have 1 over 5 divided by 3 over 4 is equal to 1 over 5 times, then we reciprocate, 4 over 3. So finally, 1 times 4, 4 over 3, 5, 15. So this is the final answer. Subscribe, like, share, and discuss with your friends. Thank you.